Hello guys, welcome once more to our YouTube channel. Today we are looking at Northwest Mock 2023 physics. We are continuing our revision process and we hope that you enjoy some physics before going into rock physics on Thursday. Let's go. Again guys, just pause the video, try reading the question and let's solve it. So you have, what is the difference between boiling and evaporation? Okay, so I've taken our time to do some really long differences here. So boiling occurs in the bulk of all the liquid, right? While evaporation occurs only at the surface. Okay. Boiling does not lead to cooling, while evaporation does. Okay. So I can define them right down here. So boiling occurs when the saturated vapor pressure equals the atmospheric pressure, while evaporation occurs at all temperatures and pressure. Okay. So we can go ahead and look at what B part says. A wet piece of cloth is hung on a line at 0 degrees Celsius in a wind current. Some of the water in the cloth freezes while the rest evaporates. Estimate the fraction of water initially in the cloth that freezes. Hey, fraction of water initially in the cloth that freezes, not just the amount of water that freezes, but the fraction. Okay, now what we are going to assume here is that, hey, the water that evaporates takes its heat from the water that freezes. Okay, because for you to evaporate, you need to absorb latent heat of vaporization now. Then for you to freeze, hey, you need to lose heat, and that's the latent heat of fusion. And so you notice that, hey, the guy that is evaporating is getting all of its heat from where? From the guy that is melting, okay? Or from the guy that is freezing, sorry. All right, so that this guy can give off latent heat of fusion. So what is the heat that is absorbed by the guy that's evaporating? Is basically the mass of the portion of water that is evaporating multiplied by the latent heat of the specific latent heat of vaporization. Then the heat that is given off by the part that was freezing is basically the mass of the frozen part multiplied by latent heat of fusion of ice, right? So notice that we can just ratio all through by ME here, so that I get MF over ME equals LV over LF, okay? And so our LV, the specific latent heat of vaporization, is 2.26 times 10 to the power 6. LF is 3.34 times 10 to the power 5. And so when we ratio these things, we get MF to ME to be 6.7665. Just keep it like that. Now remember that you want the fraction. The examiner says estimate the fraction of water initially in the cloth that freezes. So how do I do that? The fraction of water that freezes is mass of frozen water divided by total mass of water that was originally present, which will basically be what? The sum of the one that froze plus the one that evaporates. Okay, so this is the total fraction that the examiner needs you to find. But then this fraction is equal to what? We can use a little bit of mathematics here. So we can divide all through by MF. We can divide up and down by MF. So if I divide by MF here, I'm left with 1. If I divide by MF here, I'm left with 1 plus ME over MF. Why am I dividing all through by MF? Because to calculate this fraction, which is what the examiner wants, hey, I need this other fraction, which is what I already have, MF over ME. So when I divide all through by that, notice that I come up with ME over MF here, which is basically 1 over this thing, right? Because if I reciprocate this, I'll get ME over MF. And this is what I need right here. So that fraction MF over MF plus ME, the fraction of the water that froze, all right, is basically what? 1 divided by 1 plus, now notice that ME over MF would be 1 over this thing, so that's why I put 1 over that. So our fraction is 0.87. So the fraction of water that froze is very high, so most of the water really just froze, okay, than evaporated. Boom, that's it. I hope you enjoyed it, guys. Subscribe, hit the bell so we can have more revision before you take on Thursday.